Hey guys, today we're on Unit 12, Lesson 1, Derivatives of Trig Functions. So today we're going to derive and kind of learn how to use some of the most basic derivatives of trig functions. Before we begin, we have to introduce some really easy basic limit properties. So for the start of this lesson, we're going to find the limit of each of the following. So if you want to find the limit as x approaches 0 of sine x over x, we get sine of 0 over 0, which is 0 over 0. And usually we either factor or rationalize or do something to rewrite the expression. But when we go back to our original expression there, or function, so to speak, we can't do that. Okay. When that happens, I always told you guys, go to your calculator, look at the picture, see what it is. We are allowed to evaluate limits graphically. So make sure you're in radian mode and then put this function in. Sine x over x, and we're going to look at this picture. And it looks something like this. I'm just going to kind of not really make it too exact, but it looks something like that. Okay. We're concerned with what happens as x approaches 0. We know when we plug in 0, we don't get an answer. But as x gets close to 0, we can see our y values are getting close to 1. So this limit, right, even though when we plug in 0, we don't get an answer, when we plug in numbers that are close to 0, our y values are going to 1. The limit as x approaches 0 of 1 minus cosine x over x. Again, here, if we were to plug in 1 minus cosine of 0 over 0, we're going to get 1 minus 1, or 0 over 0. We can't rewrite it. So again, we're going to just go to our calculator. And this time, graphically, our picture kind of, and again, not perfect, goes like that. We care about what? We care about what's going on right here. So as x goes to 0, my y values are getting closer to 0. Therefore, the limit as x approaches 0 of that function is 0. And we'll do this last guy over here. Cosine of 0 minus 1 over 0. Again, we're going to get 0 over 0. So we're going to go to our calculator. This time our picture looks like that. And we're concerned with this area there, right? So I know when I plug in values that get close to 0, again, my y values are getting closer to 0. So this limit is 0. Now, next year in calculus, we'll go into more depth with those properties, but this year I just want to introduce them. And these are things that we're going to use again in the future. Now let's talk about the derivative of a trig function. So if f of x equals sine x, find f prime of x. Now I'm going to tell you guys up front that this is a rather complicated derivation, but once we know the rule, we can just use the rule. Okay. So I don't know what the derivative is. And when you don't know what the derivative is, always start with the definition of derivative. That limit definition that we used last unit. So f prime of x is going to equal the limit as h approaches 0 of sine of x plus h minus sine of x all over x. If we evaluate this limit as h goes to 0, we get sine x minus sine x over x, which is 0 over 0. So what we have to do is now we have to figure out a way to rewrite this. This time we can, because if you recall from your trig identity unit, we have the sum of two angles, right? That's an identity. Sine A cos B plus cos A sine B. So we're going to take that and we're going to substitute it in for this guy here. So f prime of x equals the limit as h approaches 0 of sine x cosine h plus cosine x sine h minus sine x. And that's what is the matter with this. This should be an h up here. That's what was not making sense to me. I'm so sorry about that. All over h. In the very beginning, I messed that up, but we're just going to switch it now and we're good. So once we have that, what we have to do is we have to kind of rearrange this. And I would never expect anyone to know this. Okay. But what we want to do is we want to kind of rearrange the top so we can apply some of these properties. So what I'm going to do is I'm going to get my sine x's next to each other. Limit as h approaches 0, sine x cosine h minus sine x plus cosine x sine h all over h. And now another little algebraic manipulation. Technically, each of these is a fraction. So what we're going to do is we're going to kind of make that one fraction and that another fraction. And at the same time, I'm going to factor. So here I have a sine x in each term. So that might help you see it. Sine x, factor, right? I factor that out. I'm left with cosine h minus 1 over h plus cosine x sine h over h. And now we're still evaluating this limit as h approaches 0. But now if you notice, in this term, I have cosine h minus 1 over h. And in this term, I have sine h over h. So we're going to go back up and cosine h minus 1, when I evaluate the limit as h goes to 0, that's going to be that expression over there. So I have sine x times 0 plus the limit as h approaches 0 of sine h over h is 1. Cosine x times 1. Now remember, once you evaluate the limit, your answer is your derivative function. So f prime of x is cosine x. Now we've established a rule. You never have to do that again. But now you came up with a rule for the derivative of the sine function. So let's sort of write these rules down, and I'm going to use different notation here. d dx sine x equals cosine x. This simply means the derivative. It's some new shorthand that I'm going to introduce right now. So if you see d dx, and a lot of textbooks use this notation, that's why I'm introducing it now. So this simply means the derivative of the sine is the cosine. And without having to do that long explanation again, I'm just going to give you the rule for the cosine. The derivative of the cosine is negative sine. Okay. Now we can just use these rules whenever we're asked to find the derivative of something. Okay. I want to remind you that there are other trig derivative rules, and they are going to become more complicated, but right now we're just going to stay simple and basic. So for our practice examples in this lesson, just want to differentiate. And remember, differentiate means find the derivative. So if y equals sine theta minus cosine theta, I could just say y prime equals, well, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. So this becomes term by term, cosine theta minus negative sine theta. Clean it up. Cosine theta plus sine theta. And that would be the derivative. And remember, this is a rule to find the slope of the tangent to the original function. Y equals 4 sine x minus 3 cosine x. Don't get scared by this up front. It's just a multiplier. So we would treat it just like if it was 2x squared. Y prime equals 4. Derivative of sine is cosine. Minus 3. The derivative of cosine is negative sine. 4 cosine x plus 3 sine x. So very easy stuff. If y equals cosine x minus x squared, now I have a trig and I have a strictly algebraic, doesn't matter. One term at a time. Y prime equals negative sine x minus 2x. If y equals 6 rad x plus 3 cos x, you have to remember, you have to rewrite that radical sign as a fraction power before you can begin. Y prime equals, bring the power down in front, subtract 1 to get the new power. And we're going to continue with rewriting with positive powers and radical signs if needed. Now, anything we already know how to do can now include trig derivatives. So if f of x equals negative cosine x, find f prime of pi over 2. So this means find f prime first, then plug in pi over 2. So we're just going to work on f prime first. F prime of x equals negative sine x. So f prime of x is just the sine of x. And now we're going to plug in pi over 2. The sine of pi over 2. Now this is 90 degrees. So the sine of pi over 2, if you think about your sine curve, is 1. What does this answer mean to us? Well, let's go back up to our original curve. Negative cosine x kind of looks like this, right? And at pi over 2, it means the slope of the tangent line there. If you were just to look right there, that slope is 1. Okay, so that number means the slope of the tangent line. Something else we did in our previous unit, find an equation of the tangent line to the graph of f of x equals cosine x at the point pi over 3, 1/2. Okay. Whenever we want to write an equation of a tangent line, we need the point, we need the slope, and we need to pop it into our point slope formula. My point was given to me. And if I just had the x value, I would plug the x value into the original function. My slope, we're going to find the derivative. And then we're going to plug in pi over 3. What is pi over 3? Well, we have to remember now the sine of pi over 3 is going to be the sine of 60 degrees. So you want to memorize those triangles. So the sine of 60, opposite over hypotenuse, negative radical 3 over 2. Don't worry that this is a messy number. Okay, we're just going to plug it in there and leave it. Remember, I told you, you just can leave the answer. Y minus 1/2 equals negative radical 3 over 2, x minus pi over 3. And that is your answer. Okay, don't worry about it. I should point out at this point in time, when we're dealing with this pi over 3, in the context of a trig expression, it's thought of as an angle. But when we're dealing with it in terms of the x value, then you think of it as a number. This is really 3.14 divided by 3. Okay, that's why we use radian measure in calculus. Find the x values of the graph where the line tangent to the graph is horizontal. So what does this mean to us? Tangent line means horizontal, means the slope is 0. So what we want to do is we want to set the derivative equal to 0. So we're going to take the derivative of this function, negative sine x minus cosine x, and we're going to set this equal to 0. Now, if I was to give this to you as a problem, I would tell you to use your calculator. This is not one of the algebraic kinds. This is going to be a calculator method. So all we have to do, plug this into our calculator, if you remember. Negative sine x minus cosine x. We're in radian mode. We're going to adjust our window to only see the interval that we want. 0, 2 pi. When we look at that graph now, we see our x-intercepts clearly in the screen. Second trace, we want to find the 0. So now we just have to kind of get our little cursor guy into our window. I'm going to do this one left bound. We've done this several times this year, so you should know how to do this by now. And my x-intercept is 5.498. I'm going to let you try the other one on your own, and you should get 2.356. And there we have it. Easy, nice, easy. We derived the rule for the trig derivative. Okay, so we know that our rule comes from the definition of the derivative, but once we know our rules, we can just use them. Okay, try your homework questions and we'll see you tomorrow.